Now coming to the nomenclature of coordination compounds. Already we have seen it, the different definitions of the coordination compounds. Now we'll come to the nomenclature also to the coordination compounds. Of course, while teaching you the different definitions, I have told you something about the nomenclature. Just once again, I'll tell you. I'll let you know. So first we'll go to the rules. Just we have seen it in nomenclature in organic chemistry. Here also we are having the rules. The first rule is that order of naming ions. Write down. The first rule is order of naming ions. Order of naming ions. So what do you write under that? Right, in ionic complexes, the positive ion, in ionic complexes, the positive ion, in bracket you write cation, is named first, followed by the name of the negative ion. Is named first, followed by the name of the negative ion. In bracket you may write anion. So in ionic complexes, the positive ion cation is named first, followed by the name of the anion. This you know it. That when you write any compound, first you write the cation, then you write the anion. Always. Sodium, chloride. We do not write chloride, sodium. Alright, this is the rule. The name is started with, continue. The name is started with a small letter. The name is started with a small letter. Always will start with a small letter. Like suppose if I am writing potassium ferrocyanide, the potassium P should be small letter. Alright, P should be small letter. You can say that. Whenever you start the name should be started with a small letter. The name is started with a small letter and the complex part is written. And the complex part is written as a single word. And the complex part is written as a single word. The name of the non-ionic complex, the name of the non-ionic complex are written as single word. The name of the non-ionic complex is written as single word. For example, you see here K4 FeCN whole 6. Okay. So we will write potassium first. Alright. I am not writing the IUPAC name, just I am saying you because a lot of rules are there. Not only I will be able to write the IUPAC name here. Alright. Still some more points are there. So we will start with what? The small letter potassium. Now after that we will write the the coordination number. We will write the oxidation number and the name of this complex ion. It should be written as a single word. No gap should be there in between. No gap should be there in between. That is what the first rule is saying. We should start with the cation first, then the anion. So here you know this is an ionic complex. Here the counter ion is simple ion is a cation. You can see it here because it will dissociate to give you 4K plus and FeCN whole 6 4 minus. So this is cation and this is anion. This is cation and this is anion. So cation is written first, then we can say anion. We can say that. Clear? Fine. That is what I want to say in the first rule. We should start with a small letter. Now next. After that, I have said you the nomenclature of the ligand. The next point is the nomenclature. The first point is this. The second point is nomenclature of ligand, which I have already discussed with you. Nomenclature of ligand. That is the ligand which ends in ide, ate. E is replaced by O. Like chloride, chlorido, bromide, bromido, nitrate, nitrato, oxalate, oxalato in this way. That you have read it. And that is some neutral ligands are like CO. It is known as carbonyl. CS, thiocarbonyl. The name is NO, nitrosyl. Then that is NH2, CH2, CH2, NH2. That is nothing but ethylene diamine. The abbreviated form is EN. Then C6, C5H5N. That is pyridine. Abbreviated is PY. We can say that. Got it? In this way, water is aqua, ammonia is amine, we can say that. So all this we have discussed, we can say that. This is coming under the second point, we can say that, the nomenclature of the ligands. So ligands should be named in this particular way. If Cl is there, we should write chloride. If water is there, we should write aqua. If ammonia is there, we should write amine. Alright, in this way. Now, next is, there is also some positive ligands are there, like I have just told you. NO2 plus is nitrosonium, it ends in yum, that is nitronium. NO plus is nitrosonium. NH2, NH3 plus is hydrazinium, we can say that. Okay, NO2 plus is nitronium, mind it. So, next is the third point is mode of attachment of ambident ligands. Mode of attachment of ambident ligands, we can say that. Mode of attachment of ambident ligands. Achha. What is ambident ligands? First you need to understand that. What is ambident ligands? That is some monodentate ligands, write down. Some monodentate ligands contain more than one donor atom. Some monodentate ligands contains more than one donor atom and can attach themselves to the central metal atom through one of these donor atoms. Such ligands are called ambident ligands. Alright, now let me give an example. So, some monodentate ligands, they have got more than one donor atom. For example, SCN. Now here the donor atom can be sulfur. Donor atom means this particular atom which is attached to the central metal atom. It can be sulfur, it can be nitrogen also. It can be attached from the sulfur side also, it can be attached from the nitrogen side also. Here both the atoms are the donor atoms. So when a monodentate ligands contains that is more than one donor atoms, it can be attached to the central atom by more than one donor site. It can be attached by sulfur as well as nitrogen. Then what is that ligands is called as? Ambident ligands. That is said to be as ambident ligands. For example, NO2. It is an ambident ligands. It can be attached by nitrogen as well as by oxygen. It can be attached. So again I repeat, when a particular ligand has got more than one donor atom, then it is called as what? Ambident ligands, we can say that. Clear? Mind it? Okay, fine. Now, next is here the naming. What you need to understand, the mode of attachment of the ambident ligands. So, if it is attached here SCN by sulfur, then what should be the name? How will you name it? If it is attached by nitrogen, then how should I name it? Listen. SCN means what? First of all, what is the meaning? What is the name of SCN? SCN is thiocyanate. So, it will be what? Thiocyaneto. Understand it carefully. SCN, first of all, you know the name of SCN. SCN is what? SCN is thiocyanate. You know that. So, it will become what? Thiocyaneto. E will become O. You know that. So, if it is attached by sulfur, then what we will write? Thiocyaneto S. If it is attached by sulfur, I will write thiocyaneto S. If it is attached by nitrogen, the mode of attachment of the ligands to the central atom is your nitrogen. Then it will be what? Thiocyaneto N. That's it. That is known as thiocyaneto N. So while I writing the IUPAC name, if ambident ligands is there and we need to see the ambident ligands, the mode of attachment of the ambident ligands, whether it is one particular atom or another atom. If it is in case of SCN, if it is sulfur, the mode of attachment to the central atom is, then it will be thiocyaneto S. If it is nitrogen, it is thiocyaneto N. For example, here it is NO2. If it is nitrogen, we will say it as nitro. If it is ONO, we will call it as nitrito. Alright, so here two names are there. Here two different names are there. So hence you may not have to write NO2N and nitro N and nitro O. You need not have to write, because here the two names are different. Like here both SCN, if it is attached by sulfur, we also call it as thiocyaneto. If it is attached by nitrogen, we also call it as thiocyaneto. So hence I have told you, if it is attached by sulfur, it is thiocyaneto S, and if it is attached by nitrogen, thiocyaneto N. But here NO2 can be written in this way also, NO2 and ONO. So if it is NO2, the name is nitro, and if it is ONO, so see here attachment is oxygen, this central metal atom, then it will be called it as what? Nitrito. nitrito. We can say that the naming is different. Achha. Now next is the next what you can say point is your number of ligands. Number of ligands. Suppose if a same ligands occurs, like here it is 6 times. So what we will be using the word hexa. If it is 3 times, tri. If it is 2, bi. If it is 4, tetra, in this way. So you have to use this prefix, this numerical prefix before writing the name of the ligand. Before writing the name of the ligand, this numerical prefixes has to be used. Got it? If it is 6 times, then hexa, 5 times penta, 4 times tetra. In this way, before writing the name of the ligand, this numerical prefix, that is di, tri, tetra, penta, hexa, has to be used. We can say that. We can also use in certain times as bis, tris, tetrakis, in this way. Got it? Instead of di or tri, I can say bis, tris. Instead of tetra, I can say tetrakis also. Alright, but in certain cases, remember it, in certain ligands you have to use. Here I am giving an alternative to you. You can use this bi or you can use bis. You can use tri or you can use tris. But in certain cases you have to use bis, tris, etc. In which case, for example, ethylene diamine. In the name of the ligands itself, di word is there. So if suppose ethylene diamine is twice, it is twice. En twice I am writing. Ethylene diamine is written this way. So should I write diethylene diamine? No. Why? The naming, when you write diethylene diamine, that means twice ethylene and twice amine. The meaning itself changes. In that case, what you need to write? Bis ethylene diamine. Now when I write bis ethylene diamine, it is understood that yes, ethylene diamine occurs twice. But if I write En whole twice as diethylene diamine. Think of diethylene diamine. What does it mean? Ethylene is twice, diamine is twice. No. That is what I am not speaking of. I am speaking ethylene diamine occurs twice. Suppose if it is 3 times. So should I say triethylene diamine? No. The meaning itself changes. Triethylene diamine is ethylene 3 times, diamine 2 times. No. Rather in that case, what I need to write? I have to write, not try. I have to write. What is that? Tris. Listen carefully. I have to write tris. So what I should write? Tris. Then within bracket ethylene diamine. So in certain cases, bis, tris, tetrakis, you have to write. You have to write. Like another example, EDTA. EDTA is what? Ethylene diamine tetraacetate. So if it occurs 2 times, should you write diethylene diamine tetraacetate? No. You will be writing bis, then within bracket ethylene diamine tetraacetate. So in certain cases, listen carefully, you have to write bis, tris, tetrakis in this way. But in certain cases, there is a choice for you. Now next is order of naming ligands. The 5th one is order of naming ligands. So when you are writing the ligands, it should be written in alphabetical order, and as you read in organic chemistry. Alright, as you read in organic chemistry. Suppose amine is there, chloride is there, bromide is there. I mean ammonia is there, Br is there, Cl is there. First you should write amine, then you should write bromide, then you should write chloride. Got it? Alphabetical order you need to write. But when you write in alphabetical order, bis, tris, tetrakis or bi, di, tri is not included in alphabetical order. They are not included in alphabetical order. As the rule you have studied in class 11 in nomenclature, similarly here also. Similarly here also, you have to remember it. The order should be written in, the naming should be written in alphabetical order. While writing the IUPAC name, the order of the ligand should be in alphabetical order. Remember it, the order of the ligand should be in alphabetical order. And while writing the alphabetical order, bis, tris, tetrakis or di, tri, tetra, penta, these are the numerical prefixes which are not included in alphabetical order. Got it? That you know it. Now, next is your nomenclature of bridging ligand. Point number 6. Nomenclature of bridging ligand. So I have told you already what is a bridging ligand. So write down what I said, the point, nomenclature of bridging ligand. Point number 6. Nomenclature of bridging bridging ligand. Now, for example, you can take here like H2O4 Fe. Here it is OH. Here it is NH2. Again we can say Fe H2O whole 4. Got it? So you know this is a what? Bridging ligand. Hydroxy, that is hydroxo, it will become, and NH2 is what? Amido. We can say that. Clear? NH2 is your nothing but amido. Clear? These two are bridging ligands. Now, how you should write the name of the bridging ligands? Write down. A bridging ligand is indicated by adding a prefix. A bridging ligand is indicated by adding the prefix mu. Mu. A bridging ligand is indicated by adding the prefix mu before the name of the ligand. Before the name of the ligand. The name of the ligand is separated. Continue. The name of the ligand is separated from mu by hyphen. The name of the ligand is separated from mu by a hyphen. Bridging ligands are also written in the alphabetical order. With the name of the other ligands present in the complex. Bridging ligand are also written in alphabetical order with the name of the other ligands present in the complex. Here also, that is if bridging ligand occurs twice. Suppose here OH is there. So I will be using what? Di. Numerical prefix. That I have to use it. No need to say. Alright? Clear? So for example here, how will I write the name? We can say that. See here. How will I write the name? So here water means aqua. So how many times? 4 times. So I have started with small letter C. Tetra, then aqua. Alright? Tetra, aqua. So this A comes here twice. We can write it down. Tetra, aqua. What is that? After that? Iron. Got it? Then after that, you have to write, that is the oxidation number. Oxidation number. Now how to find the oxidation number? Very simple it is. To find the oxidation number, I need to write the, here something. That is, let us say I am writing it here. A counter and I have to write, now because this is not a complete formula. So the complete formula is, let me put it here, SO4 whole twice. Anything you can put it, Cl2, SO4, Br, anything you can put it. But that should be meaningful, understood? Anything does not mean so whatever you like you can put it. But that should exist, that is what I mean to say. It should be meaningful, the formula should exist. So how to find the oxidation number? I take it as X, this is X, this is neutral, 0, this is neutral, 0, sulfate is -2 and OH is -1, NH2 is -1. What I said? OH -1, NH2 -1. So -2, here it is, sulfate is -2. So -2 means 2 sulfate is there, so -4. So how many it is? 2x. 2x, see here, x is 2x. -1, -1, -1, -1. Then -2 into 2, that is -4. Whole thing is equal to 0 because the whole compound is neutral. Because water is neutral already. I have told you already, water is a neutral ligand. So hence, 2x -1, -1, -4 is how much? -6. So 2x is equal to 6, x equal to how much? 3. So you got the oxidation number of iron as 3. Alright, in this way we find the oxidation number. Alright, so we'll write the oxidation number first, that is iron 3. Alright, then it is, what is that? I will write the bridging ligands. What I said, I will start with the hyphen, mu. Then this should be written in alphabetical order. So amido and hydroxo. Which will come first? Amido. So mu, amido. Then after that, mu, hydroxo. Again same thing, tetra, aqua, iron. We will be writing it out. Again I am saying I am not writing the full formula because I am not finished up with all the rules. We can say that. Once I finish, then I will tell you how to write the full formula. Alright, so I have started with a small letter, you can see. Then I have written the name of the ligands, that is water, aqua. Then iron, it is Fe, iron. And I have written the oxidation number. And basically I want to show you this. That is the bridging ligands is separated by hyphen and that is mu. Then the written in alphabetical order amido, and this is mu, then hydroxo. If suppose two OH group is there, so mu that is dihydroxo, that is said to be as. In this way we will be writing it out. Okay, so again same thing, hydroxo, what it will be? Tetra aqua iron, then oxidation number will be 3, and that is sulfate. Finished. In this way, if you want to complete the formula, so it will be what? Again tetra aqua. I have started with tetra aqua. See, tetra aqua iron 3, mu hydroxo, mu amido, mu hydroxo. Then again tetra aqua iron 3, and what is that? Sulfate. SO4 is what? Sulfate, not bisulfate. Got it? For the simple ion or the counter ion, we don't use a numerical prefix. Numerical prefix only we use for the ligands, mind it. And this is not a ligand, it is a simple ion or a counter ion. If 3 is there, we will not write trisulfate. If 2 is there, we will not write bisulfate, we will write only sulfate. We don't use a numerical prefix there. Got it? Mind it. So in this way, these are the rules. 2 more rules are there, we will see it in the next.